So 11.4 is on the quadratic formula. Remember what we're trying to find. We're trying to find places where our graph is going to cross the x-axis. These are known as roots. They're known as solutions. They're known as zeros. They're known as x-intercepts. And sometimes things don't factor nice and neat. So if something doesn't factor nice and neat, it's nice to have a strategy or a technique that works for any quadratic function. The quadratic formula is a formula in which you plug in the coefficients, that means the numbers in front of your x or in front of your x squared, into a formula. If I have something that's in standard form, ax squared plus bx plus c equals 0, as long as it's equal to 0, as long as it's the highest degree to the next highest degree to the constant equals 0, then you can plug things into this formula, simplify it, and you can find out where it crosses the x-axis, or you can find out where it's equal to 0. The hardest part really is memorizing this formula. The formula is negative b plus or minus radical b squared minus 4ac over 2a. Now I know this is going to be weird for some of you, but I have heard other teachers down the hallway sing this to a tune you've heard before. What tune? Jingle Bells. I'm going to try to do this without messing it up. Negative b plus or minus radical b squared minus 4ac over 2a. Hey. Negative b plus or minus radical b squared minus 4ac over 2a. Hey. Anyways, that's one way to memorize the formula. Another way is some teachers down the hall use Pop Goes the Weasel. If you don't remember Pop Goes the Weasel, it sounds like this tune. Negative b plus or minus radical b squared minus 4ac all over 2a. Negative b plus or minus radical b squared minus 4ac all over 2a. It's a lot easier eventually if you keep saying it over and over again. Eventually you'll stick to your brain. And so what we do with this is we use it to find places where it crosses the x-axis. We just make sure it has to be in standard form before we start. Negative b does not mean that b is going to be negative. Negative b means the opposite of b. Sometimes b will be negative, sometimes b will be positive. We follow order of operations, and this 2a goes into both this piece and into this piece. So don't forget to split it to see if it reduces. I'll show you some examples. So that brings us to our first example. This is number 1 on your worksheet. If you would like to do this with me, you may do so. The first thing I usually do, just to when I'm first starting, is I go, well, ax squared plus bx plus c equals 0. This is in standard form. It's equal to 0. It has the highest degree, which is the n squared. It has the x. It has the c. And then I kind of do this. I go, this is 2. This is negative 7. And this is negative 3. So that I know what each number is. The b is negative 7. The a is 2. The c is negative 3. And then I go into this formula. Notice I don't have the formula. It's hiding somewhere. So I have to go off of my memory. X equals negative b plus or minus radical b squared minus 4ac all over 2a. So you say it again and again. Eventually, I remember it to that tune. Negative b means the opposite of b. So the opposite of negative 7 is a positive 7. Plus or minus radical b squared means I'm squaring a negative 7 times a negative 7. Don't forget, a negative times a negative is a positive. And so sometimes I do that in my head. 49. minus 4 times A times C. I usually will put parentheses around it. All over 2A. 2 times the A value is a 2. Now I usually use a calculator to figure out 49 minus 4 times 2 times negative 3. But I warn you, if you do this by hand, make sure you multiply before you do the subtraction part. So 4 times 2 is 8. 8 times negative 3 is negative 24. And you're subtracting the negative 24, which means you're adding. You could also go negative times a negative is a positive. If you want to do that, you can. 4 times 2 is 8. 8 times 3 is 24. So 49 plus 24 is 73. Now I'm going to recommend that this is what this simplifies to, but the 2A goes to both parts of the numerator. So I want you to kind of get into the habit of splitting this. This is the 7 divided by the 4 and the plus or minus root 73 divided by 4. And the reason why we do that is to check to see, does this reduce? Does this reduce? 7 over 4 does not reduce. Does root 73 over 4 reduce? If you don't know, you can use a calculator. Root 73 over 4 and see if it reduces. If it does, it will. If it doesn't, it doesn't. So this is your final answer. This is where it crosses the x-axis at 7/4 plus root 73 over 4. We could turn that to a decimal to figure out where it is. We don't have to, because it says leave answers in simplest radical form. That's what that is. I have 2 more examples. Nope. I have 3 more examples for you. Here's number 2. Number 2 is harder because it's not in standard form. If it's not equal to 0. So if I want this equal to 0, I have a couple of choices. I can move these things that way or this thing that way. I think I'm going to subtract 3m squared from both sides. Then 3m squared minus 3m squared is 0 equals, and I'm going to put this in standard form, highest degree, this m squared. Next highest degree, minus 6m. Then the constant, plus 4. So we put it in order. It has to be in order before we plug things into the quadratic formula. If you still need, you put your A, your B, and your C over your values. So that way you know which one's which. And then what I do is I start going right into x equals negative b, opposite of b. The opposite of negative 6, positive 6. Plus or minus, radical b squared, negative 6 times negative 6 is 36. Minus 4 times a times a negative 3 times c is 4. 4ac over 2a, or 2 times negative 3. When I get lazy, I will punch this whole thing, including the square root, into my calculator. I'm going to type it in and then I'm going to show you what my calculator looks like. Just so you are aware. That's what I have. And I punched it in 36 minus 4 times, and I use the negative button. There are literally 3 pixels of the negative button. There are 4 pixels on the subtraction button. This is a subtraction button right here on your calculator. When I'm subtracting, I use this button. When I want to use a negative button, this one in parentheses is your negative button if you want to use the negative. it will help do that. And it simplifies it for you too, which is I love about these Casios. It's a great calculator, and they're actually quite cheap, believe it or not. For 16 bucks, they can do a lot of the math for you. So this is 6 plus or minus 2 root 21 over the negative 6. This is where I say you need to split it. You need to have that first part over the negative 6. You need to have the second part over the negative 6 because it might reduce. It might simplify. Doesn't that simplify right there? 6 divided by negative 6? What does it simplify to? It simplifies to negative 1. Does the 2 and the negative 6 reduce? Yes, it does. 2 can go into the negative 6 negative 3 times. Since you have a plus or minus and there's a negative over here, that negative sign and this plus or minus sign really sort of cancel each other out. I know this is a weird concept, but if you ever have a negative and you're adding the negative, well, that makes it a negative. And if you're ever having a positive and there's a negative, then that makes it a negative. So one makes it a positive, one makes it a negative. This doesn't change anything with the plus or minus sign. Some of you aren't used to that because we haven't done a lot of those. My final answer, negative 1 plus or minus root 21 over 3. And that cannot reduce because this is inside a radical and that's outside of a radical. You cannot mix those. Lots of interesting things. First, get it equal to 0. Plug in the quadratic formula. And then if you have plus or minus a negative, that really cancels each other out. We don't need to worry about that. So the only way this gets harder is we had some that didn't simplify. We have one that simplifies. This one, something interesting is going to happen. It's not in standard form. So number 7, I subtract 2p. And I add 5, and I add 5. I'm going to do that at the same time. This makes 0. This makes 0. Over here, p squared minus 3p plus 7 equals 0.
Just add yours to that, and then if you get a scan, send it in. If you get no scan, then just send it in without the scan.
Got it. Perfect. Thank you. So now that we have that, it's in standard form. I can go right into the quadratic formula. Negative b means the opposite. If you still need the a is an invisible 1. B, c. Negative b, positive 3. Plus or minus radical b squared. Negative 3 times negative 3 is a positive 9. Minus 4 times 1. I don't need to write that. 4a times c times 7. Over 2a. 2 times 1. Don't need to write that. Now what's interesting about this problem is this. 9 take away 4 times 7. 9 minus 28. 9 minus 28, guess what that is? That's negative 19. Earlier I told you you can't square root a negative unless you use an imaginary number. So sometimes we might have to pull out the imaginary letter I. If so, just like this one, we pull out the I, it goes right in front. This divided by 2 goes for the 3 and for this radical. My answer is 3 over 2 plus or minus I root 19 over 2. So the quadratic formula isn't too difficult. You just have to know what to plug in, get it in standard form first. Sometimes it's going to simplify. Sometimes you might have to use an imaginary unit. And then what your worksheet does is it goes into a mid-unit review. Like, hey, do you remember what we did in section 2? It asks you to complete the square, which is what we did in section 2. So if you forgot, let's go through it. Completing the square. Move the 17. Move the C value. Leave an underscore. If you forgot that, leave an underscore on both sides. That's a place where we're going to put something to complete the square, to make this a perfect trinomial square, something that's going to factor perfectly. We add something there. We add half of b squared. Half of 6 squared is plus 3 squared plus 3 squared over here. Now this is going to factor perfectly into this thing plus this thing squared. -9 minus 17 is y minus 8. All I do now is add 8. And now it's in vertex form. When it asks me what is this in vertex form, rewrite it down. And if I want to know where the vertex is, we use opposite same. -3, +8. Which is a review, but in case you forgot it, I wanted to do one more example with you guys. We're going to stop your notes right there.